This is SpaceTime, Series 22, Episode 41. Coming up on SpaceTime, the potential risk of the Taurid meteor shower, how the formation of the Moon might have brought water to Earth, and Jupiter's unknown journey revealed. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study warns that the Taurid meteor stream could pose a serious risk to planet Earth. The Taurids are generated as the Earth passes through the debris stream created by the comet 2P Encke, which itself could be a piece of a larger comet that broke apart eons ago, creating a pile of debris that's being held in its orbit by Jupiter's gravity. The Earth passes through this stream twice every year, once in June, then again in October. Included in this stream is a denser cluster of gravelly meteoroids called the Taurid Swarm, thought to be a massive ribbon of rock some 75 million by 150 million kilometres across. When it comes to the most likely extinction-level events for planet Earth, astronomers usually look at two primary threats: long-period comets from the outer solar system and NEOs, or near-Earth objects, like asteroids and meteoroids. Over the past few decades, astronomers have spent a great deal of effort trying to find, catalogue and study these primary celestial threats. Scientists think they've probably detected about 90% of the really big, potentially dangerous NEOs, and are now working hard to try and find the rest. But now, a report in the monthly notices of the Royal Astronomical Society and on the pre-press physics website archive.org claims the Taurid Swarm is a third potential source of risk, one which the authors say changes the probabilities of potential catastrophic impacts. New calculations suggest the famous Tunguska asteroid impact may well have been caused by a Taurid Swarm meteoroid. The famous event occurred on June 30th, 1908, when an object about 100 meters wide airburst in the skies above the Siberian Tunguska region in Russia. The event still haunts scientists today because of the utter devastation it caused, literally flattening 2,000 square kilometers of forests into matchsticks. The blast was so bright it lit up the night sky in London, a third of the way around the planet, with local Londoners able to read the evening newspapers without the need of artificial lighting. Tunguska remains the largest known Earth impact event in recorded history. Astronomers considered it a 1 in 1,000 year event, assuming a random distribution of events over time. But the authors of this study say their work on the Taurid Swarm, through which the Earth periodically passes, changes the odds significantly. If their hypothesis is correct, the swarm heightens the possibility of a cluster of large impacts over a short period of time. The study's lead author, David Clark, together with colleagues from Western University, simulated a large collection of 100-metre diameter meteoroids, just like the one which triggered the Tunguska event, and placed them in orbits similar to the Taurid Swarm, calculating their positions forward for 1,000 years. By analysing each object's position and motion over time, the authors calculated two optimal viewing times and telescope pointing locations for the Taurid Swarm, in order to properly investigate its real overall risk potential. According to their data analysis, planet Earth will approach within 30 million kilometres of the centre of the Taurid Swarm over the next few months, in what will be the closest such encounter since 1975. By the way, that 1975 swarm event hit the Moon, triggering the Apollo seismic sensors on the lunar surface. The calculations also show that this will be the best viewing time for the Taurid Swarm until 2032. Clark says the results have triggered a great deal of interest at the recent Planetary Defense Conference in Washington, D.C. He says there's strong meteoritic and NEO evidence supporting the Taurid Swarm and its potential existential risks. Dr. Aaron Cavosi from Curtin's School of Earth and Planetary Sciences says hazards from space remain a key focus for researchers because of the very real dangers they pose.
A lot of people think that planetary science on Earth and studying impact structures is kind of an academic pursuit. They're interesting, but, why should I care? Well, we still are very concerned about hazards from space. For anyone that needs an example of why one should be concerned about hazards, you can just look back to 2013 and that fireball that erupted over Chelyabinsk in Russia that caused all the damage and blew out windows and sent a lot of people to the hospital. That was an example of a meteor that never hit the ground. It blew up in the atmosphere. So that was kind of a small one. The events that make these impact structures that create holes in the ground that are 10 or 15 kilometers across, these are city killers. If they happen in a marine environment, they will cause tsunamis that will just be devastating in coastal environments. And so the only way that we can understand the frequency of these events occurring in the geological past is to do this difficult work to identify the impact crater record on Earth. Astronomers also shine their telescopes up to the sky and do surveys of space to count asteroids of various sizes that are orbiting and try to make predictions about what could hit us in the future. But the other half of that coin is understanding what has hit us in the past. And so there's a very real reason to continue to look for impact structures, and so we can characterize what the impact flux has been, meaning how often does Earth get smacked? We know the big one that took out the dinosaurs caused a major mass extinction. Geologically, that was only 65 million years ago. For most geologists, that's pretty much yesterday.
It's not really a case of could, but when will it happen again? Because it will happen again.
Absolutely. If you dial into NASA and other national space agencies, they spend billions of dollars per year monitoring so-called NEOs, or near-Earth objects, for this precise purpose. The impact structures that we're talking about are simply NEOs that made it through the atmosphere and caused a lot of damage and destruction on the ground. So airbursts themselves, like in Chelyabinsk or the one at Tunguska that exploded over Russia in the first part of the 20th century, these are events that are profound and damaging and catastrophic. But keep in mind, these rocks blew up in the atmosphere. They didn't hit the surface. If they were a little bit bigger and hit the surface, the damage is much more profound.
We spent an awful lot of time and effort to try and find funding for Rob McNaught to keep his program going out of ANU. We were unsuccessful, sadly. How big an impact does not having a proper Skywatch program in the Southern Hemisphere have on our ability to be forewarned of asteroids, meteors, comets, which could be on a collision course with the planet? I mean, that's half the planet that's not covered, isn't it?
One of the issues is the fact that there needs to be monitoring at all times. Different countries have different priorities in terms of what they see fit to fund, and so I'm not going to come down on one side or the other on that. There is monitoring that's going on I'm quite grateful for. Do I think there should be more monitoring? Absolutely. And the question is, what size of object do you choose to fund in order to do surveys? Because I think the recognition that objects much larger than, say, 100 meters in diameter or 500 meters in diameter are going to cause some pretty catastrophic events. But if objects on the order of between 50 to 100 meters in diameter hit urban environments, they're still going to cause a massive amount of damage. And so society has to wrestle with how much money do you want to spend in terms of prioritizing, looking for, and tracking smaller and smaller objects, because for me that's what's on the scale here. How much money do you spend versus what confidence level do you wish to know for the probability of small objects? There's a lot more of the smaller objects than there are the bigger objects, and so I think this is what that community wrestles with.
And we're also finding that a lot of those smaller objects are actually interior of the Earth's orbit around the sun, making it even more difficult to find them.
Correct. Some things we don't know that we can't see right now.
That's Aaron Cavosi from Curtin University's School of Earth and Planetary Sciences. And this is SpaceTime. I'm Stuart Gary. A new study claims Earth's water may have arrived with the formation of the Moon. According to the giant impact theory, actually it's a hypothesis, the Earth and its moon were created around 4.5 billion years ago when a Mars-sized planet called Theia slammed into the early proto-Earth. That collision turned the proto-Earth and Theia into a magma ocean, ejecting huge amounts of molten debris into orbit, which eventually coalesced and solidified to form the Moon. Until now, scientists had always assumed that Theia originated in the inner solar system near the Earth. That's supported by geological evidence looking at the composition of the Earth's mantle compared to that of the Moon. However, the new study, reported in the journal Nature Astronomy, claims Theia came from the outer solar system and delivered large quantities of water to the Earth. The study's authors base their claim on the assumption that the amount of water in Earth is surprising considering the planet formed in what they call the dry inner solar system. They say previous studies have shown that during the solar system's formation 4.6 billion years ago, it became structured so that the dry materials were separated from the wet materials, which are the so-called carbonaceous meteorites, which are relatively rich in water and came from the outer solar system, while the drier, non-carbonaceous meteorites came from the inner solar system. There's lots of evidence showing that carbonaceous meteorites were likely responsible for delivering water to Earth. But the authors contend it's unknown exactly when and how this carbonaceous material, and thus the water, arrived at Earth. The most popular hypothesis is a massive multi-million-year meteor storm 3.9 billion years ago known as the Late Heavy Bombardment, triggered by the planetary migrations of Jupiter and Saturn. Previous studies looking at the hydrogen to deuterium ratios in Earth's water have already shown that the carbonaceous meteorites rather than comets were the primary source. But in this new study, Dr. Gerrit Bood from the University of Munster used molybdenum isotopes to try and determine the origins of Earth's water. Bood says molybdenum isotopes allowed the authors to clearly distinguish carbonaceous and non-carbonaceous materials, and as such represents a genetic fingerprint of materials from the outer and inner solar system. The measurements showed that the molybdenum isotope composition of the Earth lies somewhere between those of carbonaceous and non-carbonaceous meteorites. And the authors suggest this demonstrates that some of Earth's molybdenum must have originated in the outer solar system. In this context, the chemical properties of molybdenum plays a key role, because as an iron-loving element, most of Earth's molybdenum is located in the core. The authors say it shows that the molybdenum, which is accessible today in Earth's mantle, must therefore have originated from the later stages of Earth's formation, while the molybdenum from the earlier phases is entirely bound up in the core. They contend the results show for the first time that carbonaceous material from the outer solar system arrived on Earth later in its formation. From this, they've concluded that most of the molybdenum in Earth's mantle was supplied by the protoplanet Theia, whose collision with the proto-Earth led to the formation of the Moon. And since a large part of the molybdenum in Earth's mantle originates from the outer solar system, this means that Theia itself also originated from the outer solar system. The authors believe the collision provided enough carbonaceous material to account for the entire amount of water on Earth. They say because liquid water is essential for life as we know it, means without the Moon there probably would be no life on Earth. You're listening to Space Time. I'm Stuart Gary. A new study claims the solar system's largest planet, Jupiter, probably formed about 4 times further away from the Sun than where it is now. For years, there's been growing evidence that planetary systems, including our own solar system, aren't stable, but rather are subjected to a process of planetary migration both during their birth and early in their history. You see, a lot of planets contain materials which are unlikely to condense out of the protoplanetary nebula at their current orbital distances from their host stars. Also, observations of exoplanetary systems have found evidence of numerous giant Jupiter-sized gas planets circling so close it takes just a few days or even hours to complete each orbit around their host star, environments clearly far too hot for planetary formation. So these planets must have formed further out and then somehow migrated inwards to their present locations. And astronomers have seen telltale signs of similar planetary migration in the Sun's own solar system. The Nice model and variations of it, such as the Grand Tack hypothesis, have been developed to try and explain specific features such as the composition of bodies in the main asteroid belt between Mars and Jupiter, as well as features seen in the more distant Kuiper belt and Oort cloud. Planetary migration also helps explain an event known as the Late Heavy Bombardment 3.9 billion years ago, when the inner solar system suddenly underwent a sudden upsurge in cometary and asteroid bombardment. Then there's the apparently swapped orbital positions of the planets Neptune and Uranus, as well as problems with Jupiter's family of Trojan asteroids. The Grand Trunk hypothesis suggests that Jupiter underwent a 2-phase migration after its formation some 4.6 billion years ago near the snow line about 3.5 astronomical units out from the Sun. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres or 8.3 light minutes. The idea is that after clearing a gap in the protoplanetary gas disk, Jupiter began migrating inwards to about 1.5 astronomical units, before reversing course and migrating outwards again to its current location. If uninterrupted, this inward migration would have left Jupiter in a close orbit around the Sun, like the recently discovered hot Jupiters seen in other planetary systems. But then along came Saturn. It also migrated towards the Sun, but being smaller, it migrated faster, converging on Jupiter, and then being captured in a 2-3 resonance with Jupiter during its migration. A gap in the gas disk then formed around Jupiter and Saturn, altering the balance of forces between the two planets, which then began migrating together. Saturn partially cleared its part of the gap, reducing the torque exerted on Jupiter by the outer gas disk, just as Jupiter reached somewhere between 1.5 and 2 astronomical units from the early Sun. This caused the net torque on the planets to become positive, and the pair began migrating outwards. The outwards migration continued because interactions between the planets allowed gas to stream through the gap, exchanging angular momentum with the planets during its passage, and in the process adding to the positive balance of torques and moving mass from the outer disk to the inner disk, thereby allowing the planets to migrate outwards relative to the disk. Now, this transfer of gas to the inner disk also slowed the reduction of the inner disk's mass relative to the outer disk as it accreted onto the Sun. It therefore provided enough time and allowed enough material to remain to form the inner terrestrial planets, Mercury, Venus, Earth and Mars. Meanwhile, the outward migration of Jupiter and Saturn continued until they reached a zero-torque configuration with a flared or possibly dissipated gas disk at or near Jupiter's current orbital location, about 5.2 astronomical units out from the Sun. Jupiter's grand tack, therefore, resolves the Mars problem by limiting the material available to form Mars. See, some simulations of the formation of the terrestrial planets end with Mars being similar in mass to the Earth, instead of its actual mass, which is just a fraction that of Earth's. But Jupiter's inward migration would alter this distribution of material, driving planetesimals inwards to form a narrow, dense band with a mix of materials inside 1 astronomical unit, and leaving the Mars region of space relatively empty. Planetary embryos quickly formed in this narrow band, creating the 2 large terrestrial worlds of Venus and the Earth over a period between 60 and 130 million years. The remaining scattered material left outside the band eventually formed the lower mass terrestrial worlds of Mars and Mercury. The model also demonstrates how Jupiter and Saturn drive most asteroids from their initial orbits during their migrations, leaving behind an excited remnant derived from both inside and outside Jupiter's original orbital location. You see, before Jupiter's migrations, the surrounding regions would have contained asteroids which varied in composition based purely on their distance from the Sun. Rocky asteroids would have dominated the inner region, while more primitive and icy asteroids dominated the outer region beyond the so-called snow line, the distance from the Sun, where water will always condense out of the gas disk as an ice rather than a liquid or vapor. As Jupiter and Saturn migrated inwards, about 15% of the inner asteroids are scattered outwards in orbits beyond Saturn. After reversing course, Jupiter and Saturn first encounter these objects, scattering about 0.5% of the original population back inwards onto stable orbits. The encounters with Jupiter and Saturn leave many of these captured asteroids with large eccentricities and inclinations. Eccentricities refers to how elongated an orbit is, while inclination refers to its angle of tilt compared to the plane of the solar system upon which the planets all orbit around the Sun. Importantly, some of the icy asteroids are also left in orbits which cross the region of space where the terrestrial planets would later form. This allowed water to be delivered to the accreting planets through asteroid impacts. One thing our solar system doesn't have, which we've seen in lots of other exoplanetary systems, are so-called super-Earths. And this could also be the result of Jupiter's inward migration, which captured planetesimals, causing catastrophic collisional cascades, with the resulting debris spiraling in towards the Sun and taking any forming super-Earths in with them. The 4 existing terrestrial planets could then have formed out of the remaining orbital debris left behind when Jupiter and Saturn migrated back out. Okay, so that's the grand tack hypothesis. So what's changed with this new research? Well, scientists have used new advanced computer simulations to learn more about Jupiter's journey through the solar system. And their models suggest that Jupiter was formed some 4 times further out from the Sun than what its current position would indicate. The study's lead author, Simona Perini from Lund University, says it's the first time there's been any sort of evidence suggesting that Jupiter formed a long way from the Sun and then migrated to its current orbit. Perini's evidence is based on the location of Jupiter's Trojan asteroids. Trojans are asteroids which orbit about 60 degrees ahead and behind a planet as the planet orbits the Sun. These locations are known as the L4 and L5 Lagrangian points, where the gravitational interactions between the planet and the Sun balance each other out, resulting in a stable region. Jupiter's Trojans consist of two groups of thousands of asteroids, with about 50% more of the Trojans in front of Jupiter than behind it. And it's this asymmetry which has become the key to the author's understanding of Jupiter's migration. The study's co-author and Perenni's PhD supervisor, Professor Anders Johansson, says the reasons for this asymmetry have always been a bit of an astronomical mystery. After all, why don't the two groups contain the same number of asteroids? So the pair developed new computer simulations to try and determine the reasons by recreating the course of events of Jupiter's formation and how the planet gradually drew in its Trojan asteroids. Their model shows that the current asymmetry could only have occurred if Jupiter was formed 4 times further away out in the solar system and subsequently migrated to its current position. Their models show that during its inward journey, Jupiter's own gravity would have drawn lots more Trojans in front of it than behind it. According to their calculations, Jupiter's migration went on for around 700,000 years, in a period approximately 2 to 3 million years after the celestial body started its life as an icy planetesimal far from the Sun. The journey inwards in the solar system followed a spiraling course in which Jupiter continued to circle the Sun in an increasingly tight path. The simulations showed that the Trojan asteroids were actually drawn in when Jupiter was still a very young planet with no gas atmosphere, which means these asteroids most likely consist of the same building blocks that form Jupiter's core. In 2021, NASA will launch its Lucy probe to orbit around 6 of Jupiter's Trojan asteroids to study them. The authors also suggest that, based on their models, the other gas giant Saturn, as well as the 2 ice giants Uranus and Neptune, could also have migrated in a similar way. I'm Stuart Gary. This is SpaceTime. A SpaceX Dragon cargo ship has successfully launched to the International Space Station, despite the earlier destruction of another Dragon capsule in a spectacular explosion. The CRS-17 resupply mission blasted off aboard a Falcon 9 rocket during the wee small hours of the morning from Space Launch Complex 40 at the Cape Canaveral Air Force Station in Florida, successfully docking with the orbiting outpost Harmony module 2 days later.
T-minus 15 seconds.
Falcon 9's configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff. And Dragon goes outward.
Vehicle is pushing downrange.
Power and telemetry are nominal.
Vehicle is supersonic. Vehicle is experiencing maximum aerodynamic pressure.
It's just after T plus 1 minute, and we have had a nominal liftoff of our Falcon 9. We're just about to pass through max Q, which is the maximum aerodynamic pressure that the vehicle will see. Actually, we've confirmed that we've passed through max Q. So now we will have a series of 3 events coming up in rapid succession. Main engine cutoff, stage separation, and second engine start. Main engine cutoff, or what we like to call MECO, is where all 9 engines on the Falcon 9 first stage shut down. This is then followed up by the stage separation, or the separation of the first and second stages. And then finally is the second engine start, where the Merlin vacuum engine on the second stage lights up and begins to carry Dragon to its targeted orbit. So let's listen into the countdown net for those 3 events coming up here in just about 10 seconds.
MECO.
Stage separation confirmed.
Stage 1, ready to quit.
We've just had a successful MECO and stage separation, as well as second stage startup, second stage engine glowing red there. We've also begun the boost back burn for the first stage, the nose cone from Dragon deploying and falling back down to Earth. Now that nose cone helps protect the Dragon during ascent from aerodynamic loads, but once we're in the vacuum of space, we no longer actually need it.
And stage 1 boost back burn shut down.
And in order to make its way back to the drone ship of Course I Still Love You, the first stage executes a series of 3 burns. The first burn is the boost back burn, which you just saw, and that's meant to slow the rocket down and reorient it for re-entry. Shortly after this first burn is initiated, the grid fins, which are located near the top of the first stage, are deployed to help guide the rocket during descent. Following that boost back burn, Falcon 9 then executes its re-entry burn, which slows itself down before hitting the dense parts of the Earth's atmosphere. Then last is the landing burn, which helps to rapidly slow down the first stage booster as it touches down on our drone ship. It's T plus 4.5 minutes here, and the second stage is on its way to drop Dragon off into its targeted orbit. We've had an on-time launch this morning at 2:48 a.m., which was just a few minutes ago, and ascent was nominal, and now second stage is on its way to take Dragon to orbit. So coming up here will be that entry burn that I mentioned earlier for the first stage. If we do land this booster today, it will be SpaceX's 39th booster landing. Now, it's very early in the morning here, so we don't get a lot of sunlight in that first stage view, but when we do have the entry burn start, you should be able to see a little bit of that first stage.
Stage 2 continues to follow a nominal trajectory.
Stage 1.
And there you can see. Now, we actually don't need all 9 engines for this entry burn, so we are actually only using 3 engines.
Stage 1 FTS is safed.
And there's that landing burn beginning. Again, we are landing on our drone ship. Of course, I Still Love You. It's like we're following the first stage all the way to the drone ship.
Terminal guidance.
Looks like we've got a good live view of this landing here. And we have touchdown of the first stage Falcon 9 vehicle on our drone ship. Of course, I Still Love You. That was an incredible view of that entire landing. That was awesome. So now going back to our primary mission, looks like we just had SECO, the second engine cutoff, which means we're coming up on Dragon separation soon here. Waiting for confirmation of good orbit, and we have confirmation of good orbit. Dragon has deployed.
Separation has been confirmed.
Dragon is carrying tons of cargo to the International Space Station on this mission. A small portion of that cargo represents supplies for the astronauts, which is things like food and clothing, but most of that cargo represents science going up to the space station.
The flight was the 6th to reuse a pre-flown Dragon capsule, this one having last flown on the CRS-12 resupply mission back in August 2017. This latest run saw the Dragon carry some 2,495 kilograms of scientific experiments and equipment, as well as fresh supplies for the crew aboard the orbiting outpost. Included in the manifest was NASA's new Orbiting Carbon Observatory 3, which will be installed outside the space station to monitor atmospheric carbon dioxide levels and map its sources and sinks across planet Earth. Dragon also transported the Hermes instrument, which is studying asteroid and comet formation, impact dynamics, and planetary evolution. Other research being transported aboard Dragon will study the effects of microgravity on human organs using specially designed tissue chips which simulate various organs. And there are also genetic mutations experiments tracking how well yeast DNA, altered using CRISPR-Cas9 gene editing techniques, repairs itself during spaceflight. This mission was to have launched a couple of days earlier, but had been delayed by the explosion which destroyed a Crew Dragon 2 capsule during a series of ground tests late last month. And then there was a last-minute electrical issue with the drone ship assigned to retrieve the Falcon 9 launch vehicle. See, the Falcon 9 had originally been slated to return to Earth, touching down on Landing Zone 1 at Cape Canaveral. However, that landing pad's adjacent to the test stand where the doomed Crew Dragon 2 capsule had earlier exploded. And so SpaceX decided to move the landing attempt 20 kilometers offshore using the drone ship Of Course I Still Love You, making it the closest sea landing to shore ever attempted by SpaceX. Now, while we're talking about last month's explosion, NASA and SpaceX have finally confirmed the already widely reported news that the Crew Dragon 2 capsule involved in the explosion on the test stand at Cape Canaveral was destroyed in the blast, and that the blast occurred during a live-fire test of the capsule's Super Draco thrusters. These systems are used to propel the capsule away from the Falcon 9 launch vehicle in the event of an incident during the launch or ascent phase of the mission. SpaceX is taking the lead in the investigation into this anomaly. But SpaceX's Vice President for Flight Reliability, Hans Kronenzingman, says NASA will play an active part in the investigation.
Start today with by addressing the test anomaly that occurred on April 21st this year. And please keep in mind, this is still very early in the investigation. The investigation is led by both SpaceX and NASA. Both teams are carefully reviewing the telemetry. Here's what we can confirm at this point in time. At the test stand, we powered up Dragon, and it powered up as expected. We completed tests with the Draco thrusters. The Draco thrusters are the smaller thrusters that are also on Dragon 1 and the Cargo Dragon. We fired them in 2 sets for each for 5 seconds, and that went very well. And then just before we wanted to fire the Super Draco, there was an anomaly and the vehicle was destroyed. There were no injuries. SpaceX had taken all safety measures prior to this test, as we always do. And because this is a ground test, we have a high amount of data, a huge amount of data from the vehicle and the ground sensors. But it is too early to confirm any cause, whether probable or root. But the initial data indicates that the anomaly occurred during the activation of the Super Draco system. That said, we're looking at all possible issues and the investigation is ongoing. We have no reason to believe that there's an issue with the Super Draco themselves. Those have been through about 600 tests at our test facility in Texas, and you also know about the paddleboard. We did some hover tests, so there was a lot of testing going on the Super Draco. We continue to have high confidence in that particular thruster. And as Crew Dragon is built upon the heritage of Cargo Dragon, but these are different spacecraft. Dragon does not use Super Draco and its propellant systems. Looked at all the common links between the two spacecraft. We had viewed that and we approved for flight. We approved them for flight by both teams, NASA and SpaceX in common. Also want to point out CR-17, that spacecraft has flown a CRS-12 already, which means it has been tested very well, like flight basically.
Now, as we mentioned last week, the investigation will focus on the Super Draco's thrusters, high-pressure hydrazine tanks, fuel lines, valves and control systems. This was the same spacecraft which successfully undertook the new design's maiden flight to the space station back in March. The incident has put on hold all future Crew Dragon 2 tests, including a planned test flight carrying astronauts to the space station, which had been slated for August, and the proposed commencement of regular space station crew transfer missions, which was expected to begin before the end of the year. Crew Dragon 2 is one of two spacecraft being developed to transport crew to and from the orbiting outpost under NASA's new commercial crew contract. The other, the Boeing CST-100 Starliner, is also running behind schedule, with last month's planned maiden test flight now delayed until at least August, allegedly due to launch conflicts with the Advanced Extremely High Frequency 5 military communications satellite, which is scheduled to launch in late June. See, both the Starliner and the Telcom satellite are flying off the same launch pad on Atlas V rockets. This is SpaceTime. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with a science report. Scientists have confirmed that China is responsible for a mysterious rise in emissions of an ozone-destroying chemical known as CFC-11 trichlorofluoromethane. A report in the journal Nature says researchers traced the dangerous chlorofluorocarbon, some 7,000 tons annually, to eastern mainland China's Shandong and Hebei provinces. The emissions are a clear breach of the 1987 Montreal Protocol Agreement to phase out global CFC production by 2010. CFC-11 is used as a spray foam insulation, and it's one of the most potent chemicals responsible for creating the ozone hole in the stratosphere over Antarctica and much of the southern hemisphere. The study highlights the importance of undertaking long-term measurements of trace gases like CFC-11 in order to verify the efficiency of international protocols and treaties. Well, this should be a good news story. Scientists studying the grassland earless dragon lizards of southeastern Australia have identified 2 new species. But a report in the Journal of the Royal Society Open Sciences found that one of these 2 new species hasn't actually been seen in the wild since 1969, and that's raising serious concerns that it's probably extinct. The authors say further surveys are immediately needed in order to confirm if the species does still exist. A new study claims women perform better on maths and verbal tests in higher room temperatures, while the opposite is true for men. Scientists have long known that in the battle for the thermostat, women tend to prefer higher temperatures than men, but this new research may have raised the stakes. A report in the journal PLOS ONE found the boost in women's performance at higher temperatures far outweighed the drop in men's performance, suggesting that in gender-balanced workplaces, temperatures should be set significantly higher than current standards. Minute fossils discovered in remote Arctic Canada could push back the first known appearance of fungi to around 1 billion years ago. The findings, reported in the journal Nature, claim the discovery suggests fungi appeared on Earth more than 500 million years earlier than previously expected. The fungi are microscopic and surprisingly intricate with filament-like structures. Chemical analysis suggests the fossils contain chitin, a compound common in fungal cell walls. The findings could reshape science's understanding of how fungi evolved and whether they helped to facilitate the movement of plants onto land. Meanwhile, the CSIRO has discovered gold-coated fungi. The thread-like fungus was found near Bonington in Western Australia. A report in the journal Nature Communications found they attach gold to their strands by dissolving and precipitating particles from their surroundings, in a process that could offer new clues for finding fresh gold deposits. Scientists speculate there must have been some sort of biological advantage for doing so, as the gold-coated fungi were found to grow larger and spread faster than those that didn't interact with gold. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favorite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.